Hi guys, we're going to talk about word problems today that need to use trigonometry to find some missing pieces. These are all right triangles. We haven't learned how to do trigonometry without right triangles yet. Go ahead and pause the video and write this example down in your notebooks and follow along. With word problems, I think the best way to do it is to just read the question and not try to draw yet or decipher what's what and what we're finding. Just let's read it to figure out what the problem's all about, and then we'll go from there. So a truck traveled 2,300 meters up a ramp. The ramp's angle with the ground was 49 degrees. Find the height of the truck once at the top of the ramp. Express your answer to the nearest tenth of a meter. So we need to draw a picture for this. This is always the first step, is drawing a picture. So let's go ahead and draw our picture. We have our truck, our ramp. We know it's right angle. This is going to be the ramp, so let's draw our little truck on there. It's a good truck. Okay, and our ramp is 2,300 meters. The ramp's angle with the ground, ramp, ground, so it's this guy right here, is 49 degrees. Find the height of the truck once at the top of the ramp. So from here to here is what it wants. So that's what we need to find. Call it X, call it whatever you'd like. Okay, so now that we know that, and it's a right triangle, we are going to use some old hippie caught another hippie tripping on asphalt. With this degree, let's label our H's and O's. So we always know H is opposite of the right angle. 49, that's going to be the opposite, and this is the adjacent, okay? So we have to use one with the H in it, because otherwise if we did the tangent, let's say, tangent of 49 equals I don't know over I don't know. We can't have two unknown variables in one equation. So we can't use tan. We care about O in this problem, not really the adjacent, so let's not use cos. We're going to use sine. So we're going to say sine of 49 equals opposite, which is x, over hypotenuse, which is 2,300. Now, sine of 49 is just a number, okay? So if I were to give you, let's make it be something more simple, right? If I were to give you 4 over x over 3, for example, you could solve this no problem, right? There's two different ways. We can multiply each by 3, right? Undo the division, multiplication of 3, so we would get 12. Or we can make this into a fraction because anything has a denominator of 1, and then cross multiply. So 4 times 3 is 12. 1 times x is x. Okay? So whenever something looks scary, you're like, what the heck do I do with that? Try to think about something more simple that you know, okay? Sine 49, it's just a number. It's a weird number, but it's a number, okay? So I'm going to go ahead and put this under, or 1 underneath it. And then I'm going to cross multiply. So I get 1 times x is x. Sine 49 times 2,300. So on these guys, you got to put the number first and then sine 49 degrees. It just is a little bit easier to put it in your calculator without making a mistake. If we had it as sine 49 2,300, we'd have to put it in our calculator very carefully because we are smarter than our calculators. We can't just push things in there. We got to know what we're putting in. All right. So I use the Texas Instrument graphing calculator. You're kind of to the point where you're going to need it now. So if you don't have one, get one. They're expensive, but you will use it forever. I still have mine from high school, which was 20 years ago. And then you can also find them like on Marketplace or pawn shops or whatever, used for super, super cheap. Okay. Okay. Let's look at this. So we have, we have our sine, cosine, tangent buttons. We are talking in degrees, so it's very important. You need to make sure you're in degree mode or else your answers are all going to be wrong, okay? So go up to the top, mode, and then we have right here, we want degree highlighted. If it's not highlighted, we can use these fun arrows to move around wherever we want, okay? If you don't have a TI 84, 83, it's the same buttons, all that stuff. But if you don't have a Texas Instrument and you have a different one, just Google how to do it and you can figure that out easy peasy, or use a YouTube video, okay? So I'm on degree. Now let's go ahead and put this in. So we're going to put 2,300. We don't need the multiplication sign if you don't want it. sine, and then we're going to do 49 degrees. We don't need the degree symbol because we already are in degree mode. Okay, so then we push enter, and this is our answer. We wanted to round to the nearest 10th. So we're going to look at the second number, which is 3, and we're not going to round that up because that's less than 5. So we're going to say the height of this guy is 1,735.8 meters. And that's that one. Okay, let's try another one. So Matt has a ladder that is 3 meters long. The ladder has a 65-degree angle with the ground. How high up the building is the ladder? How far from the building is the ladder? Round your answers to the nearest hundredth. So it sounds like we got 2 things to solve for here. So let's go ahead and let's draw our triangle a little different. Because it doesn't have to be. As long as it's right, it doesn't matter how we're making it, right? So let's go ahead and say, here's our ladder. This is our building. Here's Matt. Okay, so the ladder is 3 meters. And it has an angle with the ground of 65 degrees. So it's this guy. If it said it had like an angle with the building of 65, it would be up here, okay? How high up the building is the ladder? So let's call that how high up the building is the ladder. So we'll call that one X. How far from the building is the ladder? So we need that guy is a Y. Okay, same like we did last time. Some old hippie caught another hippie tripping on asphalt. This is our angle that we're working with. Opposite of the right angle is always hypotenuse. This guy is adjacent. This guy is opposite. Opposite, adjacent. Okay? Always write these guys down. It will really help simplify these problems for you, okay? So let's go ahead and find X. We know we need to use something with H since we know that value. So tan is out. So if we wanted to find X, we would need to do O and H ratio. O and H ratio is sine. So we were going to say sine of 65 degrees equals opposite over hypotenuse. Okay, and then again, I make this into a nice little fraction, cross multiply. That number goes first. Remember, multiplication is commutative, so it doesn't matter the order. It just says we have to put it in our calculator carefully. Really quick, let me say why we do that. So if we said sine 65 times 3 in our calculator would read this as the sine of, what's 65 times 3? 65 times 3. 195 degrees, okay? But if we put it in like this, it's saying 3 times this value. And sine 65 is less than 1, 0.906. So huge difference. We got this one, we got 195 degrees, and we're doing sine of that, or sine of 65 degrees. Big difference, okay? So we have sine, let's go ahead and get that. So we want 3 sine 65. You don't have to close your parentheses on these guys. If you want to, you're more than welcome to. It's above the 9, but you don't have to, okay? Only time you have to really close them is if you have more than one parenthesis going on in a problem. All right, and round your answer to the nearest hundredth. So we want to look at 3 decimal spots out, which is the 8. So that would be rounded to a 2. So we would get 2.72. 2.72 is the height of how far up the ladder is on the building, okay? All right, let's find the next one. So we have to do AH, so we want AH, that's going to be cosine this time. So cosine 65 degrees equals our A value, which we don't know what it is. We called it Y. And our hypotenuse, which is 3. We make this into a fraction equals a fraction. 3 cosine of 65 degrees equals Y. Plug it into your handy dandy calculator. 3 cosine 65. We get 1.26785. So we're rounding to the hundredth. Look at the third decimal spot, bigger than 5, which means we round that to a 7. So 1.27. So 1.27 meters is the distance from the building, away from building, is the base of the ladder. And that is how we solve trig word problems.